Let's take a look at section 3.4, where we're going to learn a couple of new rules for taking derivatives. Take really good notes, pay close attention, make sure your phone is turned off and put out of sight so you are not distracted. And let's look at these rules. We want to make sure we get these down really well because we're going to use them quite a bit. So the first rule I want to talk about is called the product rule. The product rule is used whenever you are multiplying two functions together. So if you're asked to find d dx, or the derivative of f of x times g of x. So f of x and g of x are being multiplied, two separate functions. Then the formula version of this could be written this way: f prime of x times g of x, so the derivative of f times g of x itself, plus g prime of x, so the derivative g times f of x itself. And that's it. You cannot just do the first derivative and the second derivative and call it a day. You have to apply this rule whenever you're multiplying two functions together. Now, when I was in college, my professor taught us to do this in terms of words. And it sounds a little tedious at first, but I always say these words when I do a product rule. And I'm going to encourage you to do that. If you prefer the formula, you're welcome to use that. But if the words work for you, then go ahead and do that. And we'll practice this in class too, so we have some practice with the words. But my professor would always say the derivative of the first, so the derivative of the first would be f is the first, times the second recopied, so that'd be the g function just recopied or rewritten, plus the derivative of the second, that's the g prime part, times the first recopied, f rewritten. So when you hear me do these, I'm always going to say these words: the derivative of the first times the second recopied plus the derivative of the second times the first recopied, because that always just kind of helps me keep everything straight without having to worry about what is f prime. I just kind of do them as I go through the question in using the words. So let me give you an example here. Look at number 1. They want you to find the derivative of h of x. So this is your function. Make sure you identify what's the first and what's the second. So your first, or your f of x, would be this function right here. Your second, or your g of x, would be this function right here. So to apply the product rule, and I'm going to say the words again, it's the derivative of the first. So the derivative of this would be 3 minus 4x times the second recopied, so 5 plus 4x, plus the derivative of the second, which would be 4, times the first recopied, 3x minus 2x squared. And that's your product rule. That's it. We could have, I just want to note, we could have also distributed in the beginning, or FOILed, whatever you want to call it, and just gone down the line and used power rules. But that doesn't always work either. So we need to make sure we know how to do this product rule. We can simplify this, but I'm not going to worry about it. This is a valid answer, unsimplified, so I'm going to leave it just like that. The next rule that kind of goes along with this is called the quotient rule. So the quotient rule is used, as you would expect, when you are dividing, basically, when you're dividing two functions instead of multiplying. So take a look at what the quotient rule looks like. We're looking for the derivative now of f of x divided by g of x. And I call f of x the first function again, and g of x the second function. So whatever's in the numerator, I think of as the first, and whatever's in the denominator, I think of as the second. But it's f prime times g of x minus g prime of x times f of x all over g of x squared. And I want you to note that the numerator here is the same as what you did for the product rule, with the exception of the minus sign. That's it. But the terms themselves are the same. So that hopefully will help you kind of remember what the two rules are. Again, I love the words. That's how my professor taught us to do it. So I always do this when I take these derivatives to this day. I still say these words in my head. And I say the derivative of the first, so that's f prime, times the second recopied, minus the derivative of the second, that's g prime, times the first recopied, that's f, all over, or divided by, the second function squared. So the original g of x squared. So the derivative of the first times the second recopied minus the derivative of the second all over the second squared. So let's look at this example. We've got The first, if you want to call it that, is the 5x minus 2, and the second is x squared plus 1. So according to the quotient rule, my derivative is going to look like this. The derivative of the first, which is 5, times the second recopied, minus the derivative of the second, which will be 2x, times the first recopied, all over the second function squared. And that's it. That's your quotient rule. Do not simplify that right now. Just leave it as is. There's no need to simplify. But this is it. That's your quotient rule. So we'll practice these rules in class. They're going to be very important. We're going to use them quite a bit. Next, I want to talk about the other trig functions. Previously, I gave you the derivatives for cosine and sine. As a quick refresher, d dx of cosine, remember, was negative sine x, and the derivative of sine x was cosine x. Now let's talk about the other 6 trig functions. So the derivative of tangent is going to be secant squared x, and the derivative of cotangent is going to be negative cosecant squared x. So you can kind of remember those as they go together. Tangent, the derivative of secant squared. Cotangent is the other cosecant squared. The cos go together if you want to think of it that way, but cotangent is negative. The derivative of secant is going to be secant x tan x, and then the derivative of cosecant follows the same pattern, but it's going to be negative. So it's going to be negative cosecant x cotangent x. And those are your 6 derivatives for your trig functions. So those will come up from time to time. Make sure you have those in your notes. Next thing I want to talk about is what's called higher order derivatives. And higher order derivatives are derivatives of derivatives. So previously we have talked about y prime. That's the first derivative, right? So the first derivative we might write as y prime or dy dx. Now, if we take the derivative again, we would call that the second derivative. So basically it's the derivative of the first derivative. And the notation we would use is y double prime. So y prime would be first, y double prime would be the second. You may also see this notation. If it's dy dx, we might write dy prime divided by d, or not divided by, dy prime dx. Or this notation here, and I always just call it the second derivative, but when you see this notation, that means second derivative. And we can keep going. So if we can have a second derivative, we certainly could have a third derivative, right? So a third derivative, the notation would be y triple prime. And of course, that would be the derivative of the second derivative. We could go higher than this. And generally, once we get past the third derivative, instead of writing those prime notations, we use almost looks like an exponent, but it's not exponent. We put a parentheses around it. So that would be the fourth derivative, for example. This would be the fifth derivative. This would be the 20th derivative, and so forth. They don't come up quite as often, but just be aware that it is possible. You just keep taking successive derivatives. So one practical application of the second derivative is the acceleration. And previously we have talked about position, and then the derivative of position, remember, is the velocity function. Well, now the derivative of the velocity function is the acceleration function. So if you've taken a physics class recently, you may remember your professors talking about the relationship between velocity and acceleration. And mathematically speaking, that's what that is. The second derivative of the position function is your acceleration, or you can think of it as the derivative of the velocity is the acceleration. So we might note it this way: acceleration is equal to v prime of t, or dv dt, or the second derivative of the position, if s would be the position. Okay? Be sure to make the distinction between these two ideas. So average rate of change, remember, is literally just slope between 2 points. So the slope on the interval a to b. And then instantaneous rate of change, when you hear that, remember that that is the derivative at a specific point or at x. So those terms will come up from time to time. All right, so make sure you've got your notes with you in class, and we will do some practice with these ideas tomorrow.